Yes, welcome back, grade 9 natural sciences learners. Thank you for tuning on, and I can see you are so much connected to Metric Hub and keep it up. I mean, the channel is actually there for you up to grade 12 and post metric. Today, I want to quickly work out with you power generation or electrical power generation. So, what we are going to look at some few questions that are just under electricity and power generation. As you can see on the board here, these are some of the questions that we're going to do together, calculating the cost of electricity and also explaining how electricity is generated, the functions of transformers. We're gonna talk about the three pin socket that we normally use in our households and various appliances, the color coding, and also same applies again, talk about the power generation, talking about the functions, how coal is used to generate electricity, and also other two ways in which electricity can be generated, which are environmentally friendly. I'm sure these questions you're gonna be able to uh, benefit quite a lot. So without wasting any time, we want to answer the first question. Is a three-pin socket attached to an electrical appliance? I'm sure we know and we agree that our electrical appliances, when they are to be connected to power supply sources, they have to be connected. They have to have actually power. Where does the power come from? It comes from the power from the powerhouse. So now what we just gonna want to do right now is just to quickly answer those questions. So this is it. We have got green and yellow cable. We have got blue. So we have got cable one. We have got cable one here. We have got two. We have got three. So it is a three-pin socket connected to an electrical appliance. So now, what before I answer the questions that are there, normally you need to understand that uh, we have got three wires that are there, which you need to know that which one represents which color represents which color code represents which electrical wire, and then uh, right now we are given green and yellow. Green and yellow, which color code does it mean? We have got our we have got our wire coding, our standard wire coding that is always used, which is to ensure that all wires are well connected. So what needs to be done here is that brown is always live. It is the live wire. Yellow and green, it is the earth wire. I'm saying when given an exam or given a test or an exam, this is what you always need to do. And then the blue one is always the neutral. Blue is always neutral. So if we have done this, we are done. We know these three wires. These are the three wires. So give the names of the three wires that are found inside the three-pin plug. We already gave them. We said we have got one. We have got earth wire. We have got live wire. And then finally we have got uh livey, and then the final one we said 80 livey, and then obviously the last one is what is neutral. So now one thing that before we go anywhere, before we leave this question, I want us to understand that it is always very important that as we work with electrical appliances, wire coding or in standard wire coding is very important. And then uh, what does it do? What is the function of the earth wire? What is the function of the live wire? And also neutral. So as we are still there, we can as well give the functions of saying the live wire, what does it do? It carries electricity. It carries electricity. It is the one that carries electricity. And then the earth wire, basically, what does it do? Provides safety. It actually provides safety pathway for electricity in case of faulty. So it is actually earth wire is for safety or to or prevention of short circuiting. Preventing short short circuiting, which is the same thing that we are talking about safety. And then the neutral wire, we are to understand again that it retains current, retains current. I'm sure we have got a 3-pin plug also that I did in the previous videos. Please check on it, and then we can be able to comprehensively cover all these aspects as they are relating or as they are required in our syllabus. So question 1.2 is saying, explain how the green and yellow wire contribute to safety of the 3-pin plug. Explain how it contributes to safety of the 3-pin plug. So here now, what we need to understand is that we have got a 3-pin plug, and then we say that the what we need to understand is that what is it? Explain how the green and yellow wire. We say the green and yellow wire. It is what? It is the earth wire. We say this is the what? This is the earth wire. We already mentioned that. So one, what we need to understand is uh, the earth wire is connected to the metal casing of the appliance. One is connected to metal casing of the appliance. We said that earth wire actually works to prevent short circuiting. So it is connected to the metal casing of the appliance. It is also, we are saying it is connected via the what? Via the wall plug to an earth cable in the ground. It is connected, is connected, it is connected to the wall plug. It is connected to the to wall plug to an earth cable in the ground. Earth cable that is in the ground. In the ground. And then lastly, we can also say that the earth cable has almost zero resistance. Earth wire has zero resistance. And again, so if the metal casing of the appliance becomes charged due to any fault, what happens is that the charge is safely discharged to the ground. It is uh it is actually earth wire has almost zero resistance. Almost zero resistance. It has almost zero resistance. The earth wire has almost zero resistance, which is one other advantage that we can talk about. So if the metal casing of the appliance becomes charged due to fault, the charge is safely discharged to the ground, uh, allowing charges to be safely discharged to ground. So that is how people cannot be electrocuted when we are saying the earth wire basically is connected to the metal casing of the appliance, which also connects it through the wall to the earth cable. So in the ground, so he has almost zero resistance. He has almost zero resistance, allowing the discharge to be safely discharged to the ground, hence protecting what? Protecting the users of the appliances. That's how it works. So number question 2, we have got the diagram below illustrate how electricity is generated and distributed. Electricity generation and distribution. So we have got the generating plant, we have got the pylons, we have got the transformers, and then the first question is saying briefly explain how coal is used in the generation in generating electricity to briefly explain how coal is used in the generation in the generation in the generating station to create electricity. So now what we need to understand is that coal one the coal is used to heat water to form steam. That is the first step. One, coal is used it is used to heat water. It is used to heat water. That is the first thing. To form steam, to heat the water, and and form steam. And then what happens? The steam turns the turbines in the what? In the generator. Steam turns the turbines in the generator. It turns the turbines in the generator. And then what happens there? What is next is that the turbines generate electricity. The turbines generate they generate electricity. That is one key thing. So in simple terms, coal is used to heat, to boil or to heat. It is used to heat water, which forms steam. So the steaming, which is coming from the boiling water, turns the turbines in the generator, and then the turbines generate electricity. That is how the coal is used to generate electricity. And then name two ways in which electricity can be generated, which is environmentally friendly. Two ways in which electricity can be generated, which is environmentally friendly. We are talking about ways through which electricity can be produced, whereby the production of that electricity is not endangering the environment. So environmentally friendly. This is also, we can say, eco-friendly in other ways. It can also be called eco-friendly. So the two ways, one, we can talk about the solar power. Solar power. Solar power can be one of the ways. In this case, we need to understand that we have got the photovoltaic panels that convert the sunlight directly into electricity. The solar panels convert the sunlight directly into electricity. So the question is saying name, but otherwise, if you are asked to explain, is that we have got the photovoltaic solar panels that actually convert sunlight directly into electricity. We might also have solar thermal systems, which also use the sun's heat to what? To generate steam, which then drives turbines connected to the generator. So solar power is one of the key ways that we can talk about, which uses, I'm saying, using the photovoltaic, which uses the it uses the photovoltaic panels to convert solar energy into electricity class. I'm sure all of us we have seen where power is generated from solar panels. So it is it is sunlight directly. It is the sunlight that is directly converted into electricity. And then we can also talk about the solar thermal systems. It is two under solar panels, but we can also talk about the solar thermal systems. So the solar thermal systems, what it does is that it uses the sun's heat. Sun's heat is used. It uses the sun's heat to generate steam. To generate steam. It is more or less similar to that one, and then which then drives turbines connected to the generator, which then derives the turbines connected to the generator. That is one way through which we can talk about that. And then we may also have another method which is called geothermal energy. Number two, we can also use geothermal energy, which is actually uh, uh, geothermal plants tap into the ground's thermal heat energy, which uses plants that tap into the Earth's internal heat, that tap into the Earth, they tap into the Earth's internal heat. So what we need to understand is that they can also utilize steam. They can also these methods can also utilize steam, or it can also use hot water from underground, and then underground reservoirs to generate electricity to provide direct heating. So these are basically two methods: the geothermal, the solar power, and also we can also talk about natural gas is also another method that can be used. Maybe natural gas, natural gas. So now, in this case, there is also some kind of problem which has to do with the greenhouse, which has to do with greenhouse gases, which on a long run can also not be environmentally friendly. So environmentally friendly measures, we can talk about one and two. One, solar power system, or also we can talk about geothermal energy, which uses plants that tap into the Earth's internal heat, and then this can also be used as sources of energy there. So the next question, we are going to look at the explain the sketch that shows refer to this sketch and explain how electricity is made. It's also about the production of electricity. Production of electricity. Understand? So now, what we want to quickly look at is that let's just quickly look to the questions. You see, we have got core supply also. we have got our core supply, we have got our water supply, we have got the steam lines, we have got the turbines, we have got the generator, we have got the transmission lines, and then obviously here and there we have got the condenser, and then we have the transformer, and then the electricity is taken to the houses. So now what we want to do is that we need to understand questions such as this one. We need to understand these and then be able to relate them very well, and then we can be able to understand them very well. But I think it's more or less similar to the question that we just explained now. Uh, Explain how electricity is made. So in this case, how is the electricity made? One, refer to the sketch and explain how electricity is made. So we need to understand that one, the core is used to heat water to form. We have got that one which we are saying one, the core is used to heat water to form the steam, and then the steam turns turbines in the generator, and therefore the turbines generate electricity. It's one and the same explanation as above. What we talked about, we say the core is used to heat water and then to form steam, which is therefore the steam turns the turbines in the generator, and then the turbines generate electricity. That's what we just explained as above or as from the previous question. What is the role of the transformer? What is the role of the transformer? We need to understand that the transformer, basically, what does it use? It is a machine. A transformer is actually it is actually used to transfer electrical energy. Transformer is used to transfer electrical energy. It is used to transfer electrical energy. So therefore, what we need to understand is that the electrical energy, to transfer electrical energy between circuits, and then using electromagnetic induction. Electromagnetic induction, that is the function of a transformer. It is used to transfer electrical energy between circuits using electromagnetic induction. So what we need to understand is that it also, how does it do that? It does that by changing voltage levels while maintaining the frequency. So it helps by changing the voltage levels while maintaining the frequency. Maintaining the frequency. That is one key thing that we need to understand. So basically, in other ways, what you need to look at and what you need to understand is that the transformer, it is actually important and efficient for power transmission and distribution. It is important for power transmission and distribution. That is one other additional point that we can here say. is for power transmission and distribution. That is the simplest reason that we can talk about in terms of the transformer. Uh, that is the main function of the transformer for power transmission and distribution, as well as powering wide range of electronic devices and powering wide range of electronic devices. That's what we can say. So if you can see, that is the function of the transformer in that regard. So why is it important to generate electricity through this way than nuclear power? Uh, why is it important to generate electricity in this way than nuclear power? So now what we need to understand is that in other times, as at grade 12, I mean grade 9. So now what you need to understand is that transformer basically steps down the voltage so that it can be what? It can be used in houses. It reduces the electricity voltage, so therefore it can be used what? In houses. That is the simplest definition or the simplest function of the transformer that we can give, to step down the electricity such that or step down the voltage so that it can be used in houses. The simplest definition of, I mean, the simplest function of a transformer. That's what we can say. So write down why one reason, I mean, write down on reason why, one reason why it is better to generate electricity this way than to use nuclear power. So nuclear power leave radioactive what? Radioactive waste that is dangerous. That is dangerous to humans and the environment. That is one reason why it is dangerous to use what? Nuclear power. Uh, that is one reason. So we need to understand that nuclear power, nuclear power, it actually leave radioactive, radio, radioactive waste that is dangerous. That is dangerous to humans and the environment. Dangerous to people and environment. That is the reason why it is not also, that is the reason why it is not good to use what? To use nuclear power. So we have got the next question, which is a household geyser fitted inside the bathroom consumes 120 watts. If electricity cost 2 rand 33 cents per kilowatt, how much will it cost for a geyser to heat up for 3 hours? This is just also another nice interesting question which you must understand. So now what you need to see is that in this case we are asked to calculate cost of electricity. So cost is equals to what? Is equals to power rating of the appliances is equals to power rating of the appliance, power rating of the appliance times the number of hours, multiply by number of hours, multiply by number of hours, number of hours it was used, number of hours it was used. You understand? And then multiply the unit price of electricity. Multiply by unit price of electricity. That is how we calculate the cost of electricity. So now, in this case, we are given that the power rating of the appliance is what inside the bill consumes 1,200. So it is cost. This is equals to 1,200. This is equals to 1,200 multiplied by number of hours. We are given that the number of hours is 3 hours multiplied by 3 and then multiply by the unit price of electricity multiplied by unit price. Our unit price is what? 2.33. So when we calculate that, what are we going to get? We are going to get that it's going to be 8 rand 33. We put it in the calculator, press that, you can get that it's close to 8 rand 33. That is the cost that it will take. That is the cost it will cost for geyser to heat up for 3 hours. If it heats up for 3 hours, it will cost this much, 8 rand what? 8 rand 33. And then what is happening here is that the next question, number 5, is saying name one replacement of a geyser that would be more cost effective, consume less cost effective means it is saving money, and then consume less energy from the grid and be less harmful to the environment. So what can that be? We're saying that I think I've already mentioned that can be what? It can be solar heating. Solar heating, it is more cost effective. You buy solar panels once, you install them, you are done. Consumes less energy from the grid. There is no energy that it takes from the grid, and then less harmful to the environment. Solar heating is actually environmentally friendly. So now, what we need to look at and what we need to understand is that is solar energy above every another advantage that we can say. Other advantages, other advantages of it is that one, it is always it is also readily available. It's readily available. That is one other advantage that we can have it always. And it is also a renewable source of energy. It's renewable source of energy. So I'm sure these are also additional. I mean, these the answer here is solar energy, solar heating. But I'm just giving other necessary or additional points that might also need to be taken into account when we talk about sources of energy, as to say environmentally friendly, it is cost effective, and what other additional advantages can we give? It is readily available, and also it's a renewable source of energy. Number 6, we already answered that one. We already answered it in the previous question, where we talked about the what? Where we talked about the solar energy, and also the the geo. We talked about them. So now, thank you very much for your time. I hope that you're gonna get a good understanding, and also uh we are saying you can get also a good understanding uh and enjoy the time. So we have already talked about that geothermal energy. I'm saying we already talked about them, and also we talked about solar energy. They are environmentally friendly. They are environmentally friendly sources of energy, which we cannot override anyway. They are better, they are good, and then uh, they are very good. We can also not talk about coal or natural gas. Coal and natural gas, they cause coal and natural gas, they are totally environmentally unfriendly. So that is why you see from the previous presentation, I said that natural gas, it is a traditional method of it is a traditional method. I said the natural gas, this one is sometimes you are given, and then you need to know that it is a traditional method of production of what? Of electricity. It's a traditional method. Hence, I'm saying the cleanest one, environmentally friendly one is geothermal and also solar power or solar energy. So thank you very much, class, for your time. And let's keep connected. Share to friends and family. Can we just get connected, and then we know very well that all is gonna be well. You have a beautiful stay and keep it up. Just keep connected and sharing. Don't forget to subscribe and also like and like and share to others. You have a beautiful stay. Thank you once again.